What is time? And some theories. Time in terms of physics. Did you know? Modern humans have inhabited only 0.002% of universe's age. Physicists define time as the progression of events from the past to the present into the future. Time can be considered as the fourth dimension of reality, used to describe events in three-dimensional space. 13.8 billion years ago, the universe was born. And since then time has flown by to the present day, overseeing the creation of galaxies and the expansion of space. But when it comes to comparing time, it's daunting to realize just how little of time we've actually experienced. Earth might be 4.5 billion years old, but modern humans have inhabited it for around 300,000 years. That's just 0.002% the age of the universe. Physics equations work equally well whether time is moving forward into the future, positive time, or backward into the past, negative time. However, time in the natural world has one direction, called the arrow of time. Why? The natural world follows the laws of thermodynamics. The second law of thermodynamics states that within a closed system, the entropy of the system remains constant or increases. If the universe is considered to be a closed system, its entropy, degree of disorder, can never decrease. In other words, the universe cannot return to exactly the same state in which it was at an earlier point. Time cannot move backward. In the 17th century, physicist Isaac Newton believed that absolute motion could not be detected, which meant that nothing in the universe had a constant speed, even light. By applying this theory, he was able to assume that if the speed of light could vary, then time must be constant. However, in 1905, Albert Einstein asserted that the light speed is a constant, traveling at roughly 186,282 miles per second or 299,792 kilometers per second. Time would speed up and slow down around cosmological bodies with differing masses and velocities, and therefore 1 second on Earth was not the same length of time everywhere in the universe. It was ultimately Einstein's theory that was not only believed to be the truth, but also proven to be entirely accurate. In October 1971, two physicists named J.C. Haffel and Richard Keating set about proving its validity. They flew 4 cesium atomic clocks on planes around the world, eastwards and then westwards. According to Einstein's theory, compared with atomic clocks, Haffel and Keating's airborne clocks would be slower after their eastward trip and faster after traveling west due to the gravitational effects of the Earth on the velocity of the planes. This proved that Einstein was correct, specifically with his theory of time dilation. What is time dilation? Imagine that you're on a spaceship and holding a laser, so it shoots a beam of light directly up, striking a mirror you've placed on the ceiling. The light beam then comes back down and strikes a detector. However, the spaceship is traveling at a constant speed of half the speed of light, 0.5 c. According to Einstein, this makes no difference to you. You can't even tell that you're moving. However, if other people were spying on you, it would be a different story. Others would see your beam of light travel upward along a diagonal path, strike the mirror, and then travel downward along a diagonal path before striking the detector. So, you and others would see different paths for the light that aren't even the same length. This means that the time the beam takes to go from the laser to the mirror to the detector must also be different for you and others so that you both agree on the speed of light. In some ways, this aspect of relativity can be used to allow time travel. In fact, it allows the only form of time travel that scientists know for sure is physically possible. Time travel means moving forward or backward to different points in time. Astronauts jump forward in time when they return to Earth because of its slower movement relative to the station. The idea of traveling back in time, however, poses problems. Moving back in time could cause a temporal paradox. The grandfather paradox is a classic example. According to the paradox, if you travel back in time and kill your grandfather before your mother or father was born, you could prevent your own birth. Many physicists believe time travel to the past is impossible, but there are solutions to a temporal paradox, such as traveling between parallel universes or branch points. On Earth, atomic clocks provide the most accurate track of time. The entire scientific centers are set up to calculate the most accurate measure of time, usually by measuring transitions within a cesium atom. In fact, a 9,192,631,770 transitions within a cesium atom is defined as a second, reported by Scientific American. In terms of time perception, the human brain is equipped to track time. The suprachiasmatic nuclei of the brain is the region responsible for daily or circadian rhythms. But neurotransmitters and drugs affect time perceptions. Chemicals excite neurons, so they fire more quickly than normal, while decreased neuron firing slows down time perception. In this respect, time truly does seem to fly when one is having fun. Scientists at Baylor College of Medicine in Houston say the brain doesn't actually speed up, but the amygdala becomes more active. As more memories form, time seems drawn out. The same phenomenon explains why older people seem to perceive time as moving faster than when they were younger. Psychologists believe the brain forms more memories of new experiences than that of familiar ones. Since fewer new memories are built later in life, time seems to pass more quickly. Then, will time end? The answer to this question is unknown. If the universe expands forever, time would continue. If a new Big Bang occurs, our timeline would end and a new one would begin. Only time will tell. Well, that's all. Thank you. Here are some references used in this video.